Oh, yes. It's Mr. Hyper once again, and we are going to cover the reactions of carbonyl compounds with phenylhydrazines. Last time we were looking at the reactions with the hydrazines, but this time let's look at what if it is a phenylhydrazine. It means when we say phenyl, first draw a benzene ring, then we add the hydrazine group. So we form phenylhydrazones. We form phenylhydrazines. So let me take you through a mechanism of this. And then we see how best it would be written. Right. So for the case of a mechanism, we shall have, first of all, this carbonyl compound, CH3. We shall have CH3C, or then H, hydrogen ion. So we shall form CH3C, or H with a plus, then H. It's at this point that we bring the hydrazine, the phenylhydrazine. So we shall bring the phenylhydrazine for easy. I can write it this side. So this is NH2, NH. As this one breaks, so we shall have CH3, C with OH, and then H here. Then we shall have N with a plus, H2, then NH, then a benzene ring. Then at this point that we shall have hydrogen shift. We have hydrogen shift, we shall form hydrogen will shift up to hydroxide, so it will be OH2 here, so it will be CH3C OH2 with a plus. All right, then we shall have H here. Then we shall have one H went, so we shall have N H I can have this. So now, because one hydrogen left, so that's why I have NH. So the lone pair here will create a double bond over here as I lose the water molecule. So here I'm losing water molecule, and as you lose water molecule, you are going to form right like this. Then I will have, of course, here you have N H, then you have N with a plus, then you have H, then N and carbon, we have a double bond. Then we have carbon, and we have H, and we have CH3. So from here, we lose one hydrogen. We shall lose one hydrogen. And as you lose one hydrogen, you're going to form CH3, C with H. Then between C, there is a double bond going to nitrogen. Then another nitrogen, because I lost hydrogen. So I will have, I lost this hydrogen, so I will have N, H with a phenyl. So that would be my product here. You write this product here, and this is called ethanol phenyl hydrazone. Ethanol phenyl hydrazone. So that is what we form. Then let's look at another example, and I'll do it in a different version, and you see the mechanism, but they are all the same. What if we have CH3, C double bond O, then CH3 plus, draw it like this now, NH, NH2, in place of an acid. Let's first write the mechanism and we see. The mechanism would be, so first have the ketone, that is propanol. Then we bring the hydrogen. We shall form CH3, C, OH with a plus, then CH3. So from here, we bring our phenylhydrazine. So NH, then NH2. As this one goes. So we are going to form our benzene ring. Then we have NH. Then I have N with a positive. Then one H will be here, and I put another H here. The moment I do this, it means that I want to shift hydrogen within. I don't want to write the word. However, one can use the other trend still. So we shall have OH here. Then we shall have CH3. So the fact is that on oxygen, there are lone pairs of electrons which come to hydrogen. As hydrogen, as this bond stabilizes the nitrogen. So this one, this is already hydrogen shift, OH2. This oxygen has picked the hydrogen, so it is already OH to the other side. So it is going to be NH, N, H, C, OH2 with a plus, then CH3, then CH3. So the lone pairs of nitrogen will create a double bond here as the water goes. So when water goes, it means we have lost water, so we shall form NH, N with a plus because it lost electrons, then with H, double bond has been created there, then C, then CH3, then CH3. Then here we lose the hydrogen, and as we lose the hydrogen, we shall form our final product, NH, N, double bond, C, CH3, CH3. So that is how these compounds react with phenylhydrazine. Then let's see the reaction with the 2,4-dinitrophenylhydrazine, or what we call the Brady'S reagent. A reaction with 2,4-dinitrophenyl hydrazine. It's one word. Dinitrophenyl hydrazine. It's one word. For this case, a solution of 2,4-dinitrophenylhydrazine in methanol and sulfuric acid is what you call Brady'S reagent. So 2,4-dinitrophenylhydrazine in methanol and sulfuric acid forms what we call Brady'S reagent. So in other words, we are going to look at the reaction with Brady'S. There's no one. Actually, there's no a Brady'S reagent. So carbonyl compounds react with Brady'S reagent, form carbonyl 2,4-dinitrophenylhydrazone, which is a yellow or orange precipitate. And therefore, this reagent 2,4-dinitrophenylhydrazine, or the Brady'S reagent, is used to test for carbonyl functional group. Is to test for carbonyl functional group. You need to note that this Brady'S reagent is used to test for carbonyl functional group. I want us to see the mechanism for this, right? So they'll form hydrogens. In other words, when you dissolve 2,4-dinitrophenylhydrazine in methanol and then you shake with a few drops of common sulfuric acid, okay, you form what we call Brady'S reagent. So this Brady'S reagent, as I've told you, is used to confirm the carbonyl functional group. Now, let's look at the equation for this reaction, and then we outline the mechanism also. Two, 4 dinitro. So the nitro group is on second carbon, and on the fourth carbon, 2,4. Dinitrophenylhydrazine. So the hydrazine group is here. So this one now will be reacting with this. Form, let's see. The mechanism gives you the whole thing. So we have CH3, CO, CH3, first bring an acid. From CH3, is a double bond, OH plus, then CH3. Now you bring your hydrazine. So I can draw it like this. NO2, NO2, then NH, NH2. So here we shall form, when this one happens, we shall form this. You draw a ring, then you put NO2, NO2, then NH, then N with a plus, with H, and another H. A plus can be extended this side so that I see how this H is connected. Okay. This is my H connection, then this is my plus on nitrogen. Then you attach this. Should be C, CH3, CH3, OH. Now, the lone pair of nitrogen, of oxygen, will pick the hydrogen as this bond stabilizes the nitrogen. So here, we will form NO2 here, NO2, then NH, then N, because the hydrogen has been shifted to OH, so it is OH2 here. So we have only N and H. All right. Then we have C, it's been shifted, OH2. Then we have CH3 and CH3 here. So the lone pairs of nitrogen will create a double bond here as the water goes. So as water is lost, we have lost water. So for this case, we shall form an O2, which I can write as O2N. Then NO2, then NH, then N with a plus because bonds have been lost, rather electrons, then H, double bond, you have C, and you have CH3, you have CH3. So now this is followed by loss of hydrogen. And by losing hydrogen here, ion, you form your final product, which is O2N NO2 NH and double bond C, CH3, and then CH3. So that is what we call propanone 2,4 dinitrophenylhydrazone. Propanone 2,4 is propanone 2,4 dinitrophenyl hydrazone. As simple as that. Then we have also the reaction with the arsenic-carbazide. We have the reaction with the arsenic-carbazide. Let's look at how arsenic-carbazides react with the carbonyl compound. Still, the trend is the same provided you know what it is reacting with. So with the semi-carbazide, we form a semi-carbazone. So then let's see. You have this. It's reacting with a semi-carbazide, NH2, NHCO, NH2 in presence of an acid that will form a semi-carbazone. So the mechanism can give you, may not easily guess the product when you are not very certain. So we can have for this case, we shall form OH with a plus, then CH3. And now you bring your compound there. So we shall have NH2NH, CONH2. You come here as this one goes there. So we shall form C with OH now. There is CH3, then on C there is attached NH2, then NH, CONH2. This is followed by hydrogen shift. You can use words, or you can do the way I did for other mechanisms for hydrogen shift. Which means that one of the hydrogens here will come to this, so that we form COH2, CH3, then with since those hydrogen shift, so we shall have NH, CO, NH2. The lone pairs of nitrogen here will form a double bond here as water is lost. So here we shall lose water. And as you lose water, you're going to form CH3, the double bond to nitrogen, but nitrogen will be having a plus, but H, NHCO, NH2. This is followed by loss of hydrogen. When you lose hydrogen, you form CH3, double bond N, NHCO, NH2. And you see mecarbazole formed. So that is it. So these are condensation reactions that we've looked at. And in our next video, we're going to look at reduction reactions, oxidation reactions, yeah, we're going to look at reduction and oxidation. Okay. All right. Let's look at other reactions in our next video.